Welcome to this explainer. Today, we're uncovering something completely invisible, but honestly, utterly amazing: the journey of sound. We're going to track it from its chaotic origins out in the world straight into the intricate biology of our brains. So, if you love understanding the hidden mechanics of everyday life, you are in the exact right place. Let's dive right in with a simple question. Think about your absolute favorite song, or your best friend's voice, or even just a bird singing outside your window right now. How does that invisible energy actually reach you? We experience these things constantly, but we rarely stop to think about the literal, physical journey those sounds have to take just for us to perceive them. All right, Section 1: What is sound? To understand this journey, we gotta start at the origin. At its core, sound is really just a form of energy born from vibration. And by vibration, we mean a physical object moving back and forth incredibly fast. Without that rapid physical disturbance, well, sound simply does not exist. Think about ringing a bell. This brilliantly illustrates the whole concept. When you strike it, the metal of the bell literally shakes. It vibrates. And those rapid vibrations actually push against the surrounding air, creating sound waves that ripple outward, kind of like dropping a pebble in a pond. That physical vibration is basically the starting pistol that kicks off our entire journey. Moving on to Section 2: How sound travels. Now, here's a major, absolutely crucial rule of the universe. Sound cannot travel through empty space. No way. It absolutely requires a physical material, stuff like air, water, or solids, to move. Because sound is really just the transfer of vibrational energy from one little particle to the next. A true vacuum is a literal dead end. Sound needs a medium to act as its highway. Section 3: Inside the human ear. So, what actually happens when those waves hit their destination? Well, think of the human ear as this crazy, complex physiological relay race. First up, your outer ear acts like a funnel. It collects those sound waves from the air, sends them funneling down into the ear canal, and boom, they crash into your eardrum, making it vibrate. Literally just like that bell we talked about earlier. Then, the eardrum passes that vibration along to three tiny bones sitting right behind it. And get this, these are the three smallest bones in your entire body, and they act as a bridge, passing the baton deeper into your head. Next, those tiny bones hand off the vibration to a highly specialized spiral-shaped organ called the cochlea. It kind of looks like a tiny snail shell, but it's actually the critical translation center of your ear. Inside the cochlea, this absolute biological magic trick happens. The whole thing is lined with these tiny hair cells that convert that physical mechanical vibration into electrical signals. Bam. Those electrical signals then shoot right up the hearing nerve directly into your brain. Your brain receives them, decodes them, and suddenly you hear the music. You get the joke your friend told, or you hear someone calling your name. It is just a breathtaking sequence of events. All right, Section 4: The speed of sound. Now, you might be wondering about speed. The speed of sound actually isn't constant. It entirely depends on the highway it's using. Notice how sound travels slowest in the air? That's simply because gas particles are spread pretty far apart. But look at water. Sound travels faster there. And it moves the absolute fastest through solid materials. The logic here is so elegant. The closer the particles are packed together, the faster they can bump into one another and pass that vibrational energy along. But hey, you don't just have to take my word for it. You can actually prove this whole solid speed theory yourself with that classic fun string and cup experiment right at home. You know the one: you take two paper cups and connect them with a long, tight string. When one person speaks into their cup, the sound vibrations travel directly through that solid, tightly pulled string, and the person on the other end hears it crystal clear. It's a perfect, real-world demonstration of how solids conduct sound energy. Let's wrap things up with Section 5: Test your knowledge. Okay, let's pull all this together. Based on the very start of our journey today, what is the fundamental source of all sound? Is it A, light, B, vibrations, or C, heat? Take a quick second. Think back to the bell. If you guessed B, vibrations, you are exactly right. Without that rapid back and forth movement, we would have complete and utter silence. All right, moving on to question 2. Imagine you're an astronaut floating out in the empty, pitch-black vacuum of space. Could sound travel to you? The answer, as we learned, is a definitive no. Because sound fundamentally requires a physical material, those packed together particles we talked about, to act as its highway, it just cannot cross empty space. No medium literally means no sound. As we finish this explainer, it's really worth remembering that sound is this constant, invisible companion of ours. It helps us communicate, enjoy our favorite music, and learn about the world. It deeply, deeply connects us to our environment. I want to leave you with a final thought here. Knowing what you know now, how does understanding this incredible biological baton pass change the way you experience everyday noises? Like the next time you hear a familiar voice, take a split second to picture those sound waves vibrating through the air, drumming against your eardrum, rippling through the cochlea, and sparking into reality inside your brain. Thanks for joining me on this explainer, and as always, keep staying curious.